reason that I even bring that up right now is because we're going to talk about factorial identities and today, and the idea of like working with the algebraic symbols is going to be an important thing. This idea of like taking n choose 2 and representing that as n times n minus 1 over 2 is going to be not just kind of interesting side effect. We're going to put that like front and center today. This like working with factorials. This lesson in particular and this piece that we're going to introduce is a vehicle for teaching you like to prove things again. I think it's a good idea to like prove things, but it's also a vehicle for you like getting good with working with factorials in an algebraic setting, which is not something that you need to do just here in combinatorics. It actually becomes more important as we go on into our series unit, and in calculus your series unit as well. You'll find out that later. But so we just need to become adept at working with factorials. So there are a couple reasons to talk about this. It's also just fun. So there's only, unlike your trig identities, there's only one identity you need to know. There's only one fact that's important in this game, and that's this one right here. And just like verify in your own mind that makes complete sense. It's like the definition of factorials almost, right? It's like what factorials do. That is to say, you know, if you have 6 factorial, we can re-express that as like 6 times 5 factorial. Would you agree? That's all that says. It's innocent but powerful. In fact, it says something else too. It says that 6 factorial can be written as 6 times 5 times 4 factorial. Right? I mean, the point is we can stop wherever we like. I hesitate to put this up here, but I'll put it up here anyway because it's like basically, again, this is really the only thing you ever need right here in this box. But it's certainly true that you might like to see it that way too. It's a complete, that's an immediate consequence of the previous thing. Okay, and then when you're ready, simplify this expression that involves a factorial. Everyone do it and tell your neighbor what you get. All right, here comes the answer.
think if I delay that, I
Good job. All right. Yo, did you get that? Do you want to discuss it at all? I mean, the point is on this is that like we can do this as far as we need to. We can expand the factorial out like wherever we need to, and then stop when we want to. Okay. So, that's the story. I don't know. Okay, let's try proving something. In this case, just as a reminder, proofs are fun. These identities are fun because they're kind of like fun puzzles, and also, especially on one like this, it's basically the same as the last question. I've just like given you the answer, right? So I think it's pretty clear that we start with the left-hand side and we just simplify, and hopefully we get n, right? So that would be us proving it actually, right? And by n, these parentheses here, I mean like n plus 1 choose to, right, as usual. So start with the definition. Just see if you get n. I believe in you. You'll have like equals something, equals something, equals something, equals n, which is equal to the right-hand side, and then you might say something cool like here. I don't know how far along you guys are, but I mean, certainly you've applied the definition of the combination for each of those. And you have good what I have. I haven't done any other algebra yet. I just applied the definition of a combination, right? The top thing, factorial, divided by the bottom thing, factorial, also divided by the difference between them, factorial, right? I cleaned it up a little, but not much. And then what's the big power play here? I mean, we haven't invoked any of the things we just talked about. It's the idea of like kind of expanding them out and canceling things out. We do that here. For n plus 1 factorial, we might write n plus 1. Like by definition, what does that mean? It's n plus 1 times the next thing, the next integer lower than that, which is n, times the next integer lower than that, which is n minus 1, times the next integer lower than that, which is n minus 2, and then times n minus 3, etc. How about we just write n minus 1 factorial? We can stop whenever we want, right? That's like the big takeaway here. And why did I choose to stop there? Why did I choose to stop with n minus 1 factorial? Yeah, right? Over here we can expand n factorial as far as we need to. How about to there? Again, same motivating factor. I see a reason to stop there. I see that maybe something nice is going to happen. Stopping there because I have the bottom in mind. It's not clear. The factorial is an operation that applies to the thing on the left of it only. Right? in case that wasn't made clear. So this is the fun part, right? These cancel out, and the rest is algebra from here, right? We just have n plus 1 times n over 2 minus n times n minus 1 over 2. So if you haven't yet done so, you're going to resolve those expressions. So it's now algebra land. Should be good at multiplying, combining like terms, all that. Isn't that satisfying? Doesn't it feel good to have that happen? What this says is, the other thing we should say too is, like, at the end of each one of these, we should not just like prove it and be like, yes, score, I'm good at algebra. We should also like look at the thing it said and like lay some intuition. Why should this even be true? What's going on here? Is it always true? Does it seem like it should be true? That like 6 choose 2, that the difference between 6 choose 2 and 5 choose 2 is always 5? Or that the difference that 11 choose 2 is exactly 10 bigger than 10 choose 2? Like, can we think about why would that make sense if that would be always the case? Apparently it's true because I just proved it. But like, what's the intuition there? You have something that you want to say about that? It could be, yeah, you want to say, what would that, maybe it's to do with that. It makes me think of, the first thing that comes to my mind, there are probably lots of things that could come to your mind, but the first thing that comes to my mind is yesterday, remember we said that, was it yesterday? Or no, maybe the day before that with the private key thing. We said n choose 2, it seemed like n choose 2 is related to the sum of the counting numbers. So maybe it makes sense that n choose 2, if we go up to n plus 1 choose 2, we add the next counting number, n. So maybe there's that there too. Maybe, I don't know. But yeah, there's some like interesting things happening behind the scenes maybe too that would like lend some intuition to actually what's going on too, not just like pushing symbols around. Try another one. I don't mean this one to be any harder at all, just like another form of practice. In fact, I'll have one of you come up and do this in a second. It's not meant to be harder necessarily. I might start with I don't think it's too much of a giveaway. I might start with the left-hand side again. See, just go with it. And see if you get n squared. I hope you do. Right? And if you're the one to do it, then come up and grab the pen. If you're the person to do this, then hop off the door. Who's going to do this? If you got n squared, then you should be the chosen one.
No, I mean, like, you want to go up. Oh. What? I'm working on it.
So bad. That's also a problem.
Saying someone, you understand what I did?
Yeah, but I also didn't get that, so
Yeah, you should.
I just need to be angry for a really long amount of time. That's kind of how I feel.
Said like 6 times 5. Like 6 by 2 is 6 times 5. Oh, right. Are you sure? Wait. Yeah. So basically, like, what you're gonna do. So does it make sense that n plus 1 factorial equals n plus 1? I know. Because if you multiply, it's just say you have like 1, 2, 3, 4, 5, 6, 7, as that equals about 7, so it's not like 6 times 5.
We were just like that last year.
Yeah, I slept last year. Didn't fall asleep.
I still say that's n factorial.
How's he doing?
When you multiply by that number plus 1, will that be 7 factorial? Yeah.
Because if you compare the number of hours that you are awake versus the number of hours you are awake, discrepancy. No, it's not. It's the number of hours you didn't sleep.
By the way, we are going to have a quiz.
What? Oh. It's not on this though, right?
No, nothing.
One number greater.
Homework 5, the one that goes with this,
It'll give you.
will not be talked about until Tuesday, actually. Because we're going to have a peer review thing on this.
So, and then does it make sense that n factorial is
Your eyes.
Why?
n
I did a little more.
So then if you combine those together, then you can say n factorial plus n plus 1. Now instead of saying that,
Wait, you do a quiz? The quiz tomorrow will happen whether we have a delay or not. It's short. It'll be alright. People are saying we are, so I don't know.
yeah. It's not so, but it makes sense. It is so insane. It's actually really disappointing because I have no clue how to get that it actually goes through the equation.
It should be right.
Oh, it hurt.
Alright, case closed. Maybe you saw him doing this as he went. Do you need a play-by-play at all? I mean, I think it's pretty clear. The big part, the big power play is like not in the algebra down here, but this piece right in the middle where he's like canceling out the factorials. We're using those properties that are new to us maybe that we haven't really worked with a lot before. So the first step up here, I'm just going to go line by line here. He's doing n, choose n minus 2. And that simplifies to this. And n plus 1, choose 2, and that simplifies to this. Do you agree with that? Those first 2 lines of work? Stare at it for a second and make sure that you really do agree with it. And then, this is the big power play. He expands out n factorial on top until he has an n minus 2 factorial factor up here. You know, the motivation again is so that something can cancel out. Over here, n plus 1 factorial, he does the same thing. It's a very similar trick to the last one. That's what I meant. I thought you'd be successful in this one. Stuff cancels out, and then algebra happens. That's how it works. Okay? Does that work? Did you prove it? How'd you do, Teo? to prove it?
I'm close.
Yeah, okay. All right, well then don't look up there. You can finish it. Maddie, did you do it?
No, I have questions.
You have questions?
Is that okay?
It's okay.
So I don't understand how with the first part of it, how
Hey guys.
Oh.
First part.
Oh wait, no, never mind. I've been doing this in like a way that just doesn't make any sense. I forgot to subtract the n from the n.
All right. I'm going to put another one up here, but it's not one that I'm going to prove right now. But just look at it and just verify that the proof is only like one line, right? Are you ready? This is a property that we've talked about a lot. Oh, wait, so we're not. You can prove it just now in just like 2 seconds. It's like only takes a second. It's one line. There's really not much to prove once you write the definition of both sides down. You're done, right? Basically, so you can try proving that. It's like one of the things we've spoken about before. That 5 choose 3 is the same as 5 choose 2, or whatever. So try it, and then let's try another one. All right, this is the one that I'd really like to do. The other one was n choose r is the same as n choose n minus r, right? So you can verify that on your own. But let's try one that's actually somewhat tricky, and I'm going to run through this with you a little bit just to show you how this is going to work. There are a couple like this on the homework, not too many, but I'm going to start with the left-hand side, but it requires that we also think hard about the right-hand side because it's not obvious that when we get there, we'll know that we're there. The left-hand side is this. We'll work on it. The right-hand side is n plus 1 factorial over r plus 1 factorial times n plus 1 minus r plus 1 factorial, which is, I'll leave the numerator the same, which is r plus 1 factorial times, in the bottom, yeah, n minus r factorial. So that's what we'll see. If we arrive there, we'll know now, okay, that we're there. It's just good to like have an eye on the prize, okay? So here we go. This part's not too bad. N factorial over r factorial times n minus r factorial. That's the definition we know and love. This is n factorial over r factorial times n minus r minus 1 factorial. Is that okay? It's n minus quantity r plus 1. And now this is the tricky piece right here, because before, in the last couple examples here, we've been able to like cancel something out here right off the bat. And I admit that n minus r factorial is a factor that's contained in n factorial. True story. But I don't know how far to expand it out until cancel it out. Like I symbolically, I'm not really able to do that. So even though I do know that could maybe happen, it's a little bit tricky. The only recourse I really have right now is to start adding these fractions together. That might sound daunting, but they're actually pretty close to each other. Look quick. Oh, sorry, this is an r plus 1 over here. This is an r plus 1. Excuse my error. Get your whiteout out. Okay, so r plus 1 factorial appears over here, and over here in this denominator there's an r factorial. That seems really close. They're just off by a factor of not 1, but r plus 1. So that means if I multiply this guy by r plus 1 on the top and on the bottom, then I'll have an r plus 1 factorial in the bottom of both fractions. That's really swell. Okay, and over here, I also make the observation that n minus r minus 1 factorial is very, very close to n minus r factorial, right? If I were to expand n minus r factorial out, what would the next thing be? What's the next number, one integer lower than n minus r? Oh yeah, that's right, n minus r minus 1, isn't it? So these are really close too. This is a factor. The second thing is a factor of this first thing. So maybe I can multiply this by n minus r over n minus r. And when I do, I get that. We're almost there. Did you see what I just did? That was like, this is the big move right there. Because I just got a common denominator. Yeah, Sue.
Why does the n minus r minus 1 change to n minus r?
Because I multiplied by something that's 1 bigger than it, namely n minus r, right? So it's like multiplying 5 factorial by 6. Don't you get 6 factorial? So here I'm multiplying n minus r minus 1 times factorial times n minus r, and I get n minus r factorials. All right, and then hopefully, if you already seeing what's beautiful here? The denominator I have is the denominator I want, isn't it? So hopefully the numerator just works out. Let's keep going. We get r plus 1 times n factorial plus n minus r times n factorial all over the common denominator. Factor out an n factorial, mainly just because it's like irresistible to do so, right? And we have an r plus 1 plus n minus r if we collect like terms there. And what does that come out to there? That's nice. Just n plus 1 times n factorial. In the numerator, what is that? That is the thing we want, isn't it? N plus 1 factorial. All right, then the last thing to say on this too is we have just proved something that happens in Pascal's triangle that we talked about yesterday that we can now finally make the connection. A number in the Pascal's triangle plus the number next to it, isn't that what this is? Same row, equals the number in the row below it, right? That's actually what we just proved, isn't it? So, look at it, you'll figure it out, right? That is like 5 choose 2 plus 5 choose 3 equals 6 choose 3, right? All right, like I said, homework is not